Today we will see about the preliminaries of decision tree, and today I will take the class on decision tree. Decision tree is a huge chapter, and we will discuss on decision tree today and tomorrow. And on Saturday we will proceed towards random forest. So before proceed, I will, before entering into the decision tree, I will likely to interpret something about the decision tree. So decision tree is another kind of classification problem, which is used in the supervised machine learning. In supervised machine learning, the we see this from the part of classification problem. We see the logistic, we see the support vector machine, SVM, KNN, and today we will see about the decision tree. Now, random forest is also a classification problem, and which is based on the supervised machine learning. These classification problem is also used in for various kind of designing part. Also, this classification problem also used for designing various kind of the linear and non-linear systems. So on the context of the supervised machine learning, the systems can also be designed by using the reinforcement learning and unsupervised machine learning too. But we can also design the system based on these classification analysis and the supervised machine learning also. Now, decision tree is is a classification problem, and it's also used for the statistical analysis too. Decision tree also plays an important role in statistical point of view. So decision tree can be developed in a stochastic scenario, in a stochastic manner based on the data, and that is there. The stochastic means that it can be developed on the based on the probability function. Now, based on the probability function means the probability functions, we know that it is of two types, that is continuous and discrete. So decision tree can also be used for both as can be implemented both as the continuous and the discrete function. Now, what is a decision tree? So if I say or interpret in this way, sorry, Suppose a card is swiped. What is the outcome? The outcome may be 2. That is, the card may be damaged, or the card is not damaged. So if the card is damaged, then this portion is declined. It is declined. If the card is not damaged, then again we move to the 2 section. One is the card is inactive. Another is the card is active. The card is active. From here, we can also, if the card is inactive, then this portion is also declined. So if the card is active, then we can also proceed in further way. Again, we can divide it into 2 parts. That is, where is this thing? That is continuing from the card is active. We can
you please zoom your screen?
Is it not visible? From the card is active, then it again divide into two parts. That is, it looks like fraud. And from this specific section, it does not looks like fraud. So again, from this node, again, I can conclude one conclusion. Again, from this, I can conclude another conclusion. So in this manner, a central node with corresponding the child node develops, and we get a tree-like structure. And the tree-like this tree structure is based on the certain condition, the condition which is which is mentioned in the node. And with that particular condition, we draw the two conclusions. That is, we draw the two terminating nodes. So this is so decision tree. In other words, I can say it's a process of segmentation. The process of segmentation the in terms of the parental node with respect to the child node. So this segmentation is based on this. What I am discussing is that is based on this stochastic development or stochastic scenario based on the data that is been referred. With based on the stochastic data or the stochastic scenario, the segmentation takes place. So objective of the segmentation in a supervised learning algorithm. The objective of the segmentation is a supervised machine learning algorithm with a whose with the business objectives and aim of generating an actionable group of segments that is based on that is the basis of the stochastic scenario. That is, it means that that the each and every segment, that the each of this parental node is divided into the two uh, child nodes is based on this probability of occurrence. That is, the stochastic here means the term stochastic here means the probability of occurrence. probability of occurrence of what? Probability of occurrence on the basis of the certain condition, and with that basis of the certain condition, the two child nodes develop. So the basis of the parental node, the two child node develops. The basis of the condition, the two child nodes develop. Now, mm, now suppose n is equal to 1000, and suppose the infant mortality rate IMR. So if I want to calculate the IMR, infant mortality rate, with respect to the population, and this n and this population is subdivided into the certain districts. So n stands for the districts. So IMR is the infant mortality rate. So with 1000 districts, the infant mortality rate IMR, it is calculated that IMR is 25%. Right. We divide this thing into three parts. One is the city, city having n is equal to 300 with IMR rate, is suppose 12.5%. Similarly for town n is equal to 400 with IMR rate 15%. Similarly for village, n is equal to 400 with IMR rate 41.2.5%. This tree is again subdivided into two parts. That is a high income uh, with the IMR rate of 2%, and the low income people has the IMR rate of 15%. So in village is again subdivided into two parts. One is the presence of hospital, the IMR rate is 8%. IMR rate is 8%. And with absence of hospital, the IMR rate is the IMR rate is supposed to be is high, that is 46%. So this is the kind of decision. So there is a parental node from which we can terminate the three child nodes. So this basis on this condition, we are deciding on this deciding conditional factor. We are deciding the three child node over here, and from this conditional factor, we are terminating. We are concluding the three child node. One is for the city, another is for town, another for the village. So with the city, the IMR rate or infant mortality rate is 12.5%. With town, the infant mortality rate is 15%. With village, the infant mortality rate is 41.25%. So from that parental load, then from here, from this parental node, we conclude to the two child node over here. That is for high income group, the infant mortality rate is 2%. With low income group, the infant mortality rate is 15%. And for village, the absence of hospital, in presence of hospital and absence of hospital. In absence of hospital, the infant mortality rate is 8%. In presence of hospital, the infant mortality rate is 8%. In absence of our hospital, infant mortality rate is 46%. So we conclude this is also a decision tree because each of the child node is concluded with respect to this parental node. So the parental node, with the help of the parental node, we can conclude the following child nodes. So each group of observation is termed as node. So every observation is termed as this node. So this is the one observation. On this particular observation, we can conclude from one child node. This is another child node. This is another child node. With the help of this particular observation, we can again draw the two child nodes. On the basis of this particular observation, we again draw the two child. In this way, a decision tree is developed. So a node is split into the two nodes. The master node is termed over here. There, the master node is this one. So this master node is termed as the parental node, and the new node which is created is referred to as the child. So the nodes where the tree ends, that is the node that cannot be splitted further. That node is termed as the final node. So these are the nodes where the tree ends, and from here we cannot terminate, we cannot split it into the further nodes. So these nodes are basically the end nodes. Have you understood?
Yes, sir.
So you know about the entropy? Any idea? Have you known the entropy? What is entropy is all about?
Yes, sir. Finding the accuracy.
So what I am want to explain uh, earlier is that this this thing, that is a decision tree. We know that it's a flow chart like tree structure where internal node uh, represents the features. So from this classification problem, uh, previous classification problem, and we will see up to the random forest. The model or the dataset is designed with certain features, and with the respect to the features, we train the set and test the set. So here basically the features means the attributes. So here also the internal nodes represents the features, and the branch represents the decision rule. Right. So and each leaf node represents the outcome. So the branches represents the decision rule, and the leaf node, that is the terminating point of each node, is termed as is basically the leaf node. The terminating point are basically the leaf node. So we know that the topmost node is a root node, and it learns to a partition on the basis of attribute value. So if the partition of the tree in recursive manner occurs, we will, and this manner, then we call it as the recursive partitioning. And the flow chart, it helps the visualization of the the decision tree, which can we can easily able to understand and interpret. So decision tree is, as I told you, that it's a supervised machine learning algorithm classification problem, and obviously the it shares an internal decision making logic which is not available in black box type algorithms such as neural networks. So this tree has the tree and decision tree is much faster, or training time is much faster compared to the neural networks. In neural networks, we have the 3 layers using the radial based function or RBF, where we use the input layer, hidden layer, output layer. But those layers are not is not necessary in the decision trees. So since it is much faster, the time complexity of the decision tree as is a function of number of records and number of attributes in the given data. As we know all these things. Now, so this is the data. We know that we have to train and test the data, and for training the data, that is for building the model, we use different types of the classification algorithm. And for building the model over here, we use the training the data, that is the decision tree generation, and we break the data set into the smaller subsets. The model evaluation or testing the data, we know that the model can be evaluated by the performance evaluation measures. We call it as accuracy, precision, and we call starting from the other previous classification algorithm which I had discussed. So here we use either various gain factors, and these are basically the parameters of the decision trees. Different kinds of parameters we use over here. That is the information gain, gain ratio, gain index, and so on. After that, there is coding part. The same thing, all of the most of the algorithm has more or less is identical. That we have to train that particular data set. After that, we test the data set. We have to we have to develop on the classification problem, and we have to create that classification analysis, and we have to using the different by using we can by importing various kind of the library functions. And after that, we will predict the data, and with the prediction of data, we will calculate the various accuracy and so on. So these things are applicable to all types of the classification problem. Now, Information gain causes the decrease in entropy, and information gain computes the difference between entropy before split and the average entropy after the split of the dataset based on the attribute values. So it is basically a dichotomy. So the formula is given over here. Information gain is equal to the minus of summation m tending from I equal to 1 to m, or pi log base 2 pi. So this pi is the probability that attribute of a tuple in D belongs to a class. So it is basically the attribute. This pi is basically the attribute of is the probability that arbitrary the tuple in the D belongs to a particular class. Here also the two formulas, the gaining formula with respect to the information gain. The information gain D1 with respect to the decision tree is equal to summation of the vector G starting from G equal to 1 up to B. That is, we are taking the absolute value over here, and x equal to e for B, particular decision, one decision. So I just gave today an introduction of decision tree. Now I will discuss these things in detail on tomorrow. All these things details on tomorrow. So tomorrow I will also start with this 9 p.m. and I will discuss all the parameters of the decision tree and the coding section too. Have you understood what I had told today?
Yes, sir.
Oh. So here tomorrow we will discuss the remaining part of the decision tree. Right? Okay.